Hey guys, Mr. Marone here. Welcome back in. We are now in section 10.2, which is really just an extension of 10.1, where we talked about arcs and central angles, and we started to find the portions of the circumference. Well, now we're going to find portions of the area of a circle. The best example of this, and it's really kind of a silly one, is we're going to be finding the area of pieces of a pizza. Instead of the whole pizza, we can easily find the area of the whole pizza using our area formula. Now we're going to find just a portion of it. So just to get us set up, we're going to deal with the area of a circle, and the area formula is pi times radius squared. There's only one. It's not like circumference where you have two different ones based on radius diameter. So if you're given the diameter, you do have to find the radius. And we're going to look at what are called sectors. And sectors are just a portion of the circle. And as you see there, I wrote just a slice of pizza, and you can kind of see it down in this picture down here. So we have, for the area of a sector, we really have two different formulas. They're the same thing. It just brings in the account of our degree measure versus our radian measure. Remember, we said that 360 degrees equals 2 pi radians. We talked about that last time. So if I'm dealing with degrees, it's basically taking the area of a circle, so pi r squared, and we're only going to account for the portion of the circle that we have. So it's going to be theta, our angle measure, over 360 times pi r squared. So you're just taking a portion of your figure. Now, when it comes to radians, we've already got pi involved. So it's just theta times radius squared. And that gives us the area of a sector there. So if we're looking at this example over here, this one would be 78, which is the arc measure they gave me for nm, over 360, and we're going to multiply that by pi 10 squared. So if you do that quickly, we're going to leave everything in terms of pi, just like we did with our arc length. We're going to leave everything in terms of pi. So 10 squared is 100, so I've got 78 over 360 times 100 pi. And if we do 78 divided by 360, that gives me basically 13 over 60. So if we just multiply that times 100, we're going to end up with 65 over 3 pi. Seems like a really weird answer, but that is an exact answer. So 65 over 3 is the simplified version of 100 times 78 over 360. If you're wondering how I did that, I went to the calculator and I simplified 78 over 360, and then I multiplied by 100. And because I've done it as a fraction, it keeps everything as a fraction. So you can certainly do that. Calculators are most welcome here. The big thing is just don't put in the pi. That's going to give you a decimal, and I know how you guys feel about decimals, so we're just going to leave everything in terms of pi. And this one would be centimeters squared if we're using our units of measure. So I've got 3 examples here. I want you guys to try each of these after I set up this first one. So this first one is 165 over 360 because I have a central angle. So that means this arc is going to match it. And that's going to be multiplied by pi times 3 squared. So I've got 3 squared. So 165 divided by 360. As a fraction is 11 over 24. So I've got 11 over 24 times 9 times pi. And that equals 33 over 8 pi. That's my final answer there. Go ahead and try B and C. B is going to use the degree formula. C is going to use the radian formula. And when you come back in, the answers will be there. Okay, welcome back in. So in my first one, if you try to simplify 59 over 360, it doesn't work. So you just multiply that times 100, and you end up with the lovely fraction of 295 over 18, and we're going to attach pi to that. And in my last one, I'm just going to multiply whatever I was given here, 3 pi over 2, which is actually 270 degrees. And I'm going to multiply that by 4 squared, and I end up with 24 pi when I do that. So now, in this example, notice what they're asking for. They want the area and the perimeter of sector QNR. So in order to find the area, that's the sector, that's what we are just going to do, that we've been doing. They gave us 260 for Q all the way to R this way, so that means this is 100 here. So I've got 100 over 360 times 6 squared pi. And if I do 100 divided by 360 and turn it into a fraction in my calculator, I've got 5 over 18, and I'm going to multiply that by 36. So I've got 10 pi as my final answer for the area. Since it says round to the nearest tenth, then we can actually multiply by pi. So you do 10 times pi, and you get 31.441, or just 31.4. So that's area. Now, for perimeter, they want to know, we know that this is also going to be 6 because they're both radiuses, or radii. So we need to find this portion here, which is going to be our arc length. So I'm going to do 100 over 360 times 2 pi 6. Or in other words, I'm going to do 12 times that 5 over 18. And that gives me 10 over 3 pi, which when we get our 1 decimal place, gives me 10.5. Now, if they want the perimeter, we also have to add in those extra 6's. So I've got 10.5 plus 6 plus 6. So my perimeter is going to be 22.5 there. Area was 31.4. Perimeter was 22.5. So a little bit of an extra trick, knowing that I have to add the 6 and add 6 more for the perimeter of the figure QNR. So you guys have some practice with this. Make sure to bring in any questions you may have. Hopefully this isn't too much for you. I know that circles can start to become a lot, so just kind of keep your cool. Make sure you're practicing. Practice is the only thing that makes you better at these circles, unfortunately. If you have any questions, bring them into class tomorrow, and I'll see you then. Have a great night, guys. Bye-bye.